Let's take a look at this check on neutralization and titration. The first question asks you to describe and diagram how to use titration to determine the unknown concentration of an acid using the known concentration of a base. In this diagram, I have added a little bit of description, and so on the left-hand side, you'll see that we have our initial setup with our burette, and inside of our burette, we have, in this case, our known is going to be our base, and then our unknown is going to be our acid. You could flip this around and you could have an unknown acid, an unknown base and a known acid, and so that's a possibility as well. And so the general process is that we just add this base to a measured amount of our unknown acid until we reach equivalence point where the hydrogen ion concentration is equal to the hydroxide ion concentration. And then we analyze that data. So we stop when it changes color, and then we're going to analyze that data just like we would in a regular calculation. And so let's go ahead and do a sample calculation down below. So this question asks, what is the molarity of acetic acid if 10 milliliters of the solution is neutralized by 5 milliliters of a 0.1 molar sodium hydroxide solution? So the first thing I want to do is I want to start with my balanced equation. You can also just know that it's a 1-to-1 when these neutralize, but I think it's always nice to have this. So we have our HC2H3O2, which is aqueous, plus our NaOH, which is also aqueous. And those are going to combine to form H2O, which is liquid, and then sodium acetate, C2H3O2, which will also be aqueous. Those are actually spectator ions. So if we were looking at the net ionic equation for this, so the net ionic you're going to have an H plus an OH minus, and those are going to form H2O. And the H2O is liquid. It is the new thing. Everything else is just spectator ions between the sodium and the acetate. So just if you're curious about that. So in our case, this is our unknown. Our acid is our unknown, and the unknown is going to be the sodium hydroxide. So we want to go ahead and determine what what the liters are for each one of these. So we're going to go from milliliters to liters, and in order to do that, we're going to divide by 1,000, or you can move your decimal place 3 places to the left. And so for our HC2H3O2, we originally had 10 milliliters, and so 10 divided by 1,000, we're going to get 0.0100 liters. And for our sodium hydroxide that was added in order to neutralize this, we have the 0.10, molar. That's not what I want. I want the 5 milliliters. And so that's going to be equal to 0.0050 liters. Okay, and so we want to have our volumes in liters for this. The next thing that we're going to do then is we're going to determine the known concentration moles. Okay, so we're going to determine the known concentration moles, which for us is going to be our sodium hydroxide. And so what we do is we take the concentration of our sodium hydroxide, which was 0.1 molar, and we're going to multiply that by our liters. So we're going to take our 0.0050 liters and we're going to take, and remember that molarity is moles per liter, so that means that we have 0.10 moles per liter. And when I calculate this out, I don't have my calculator ready. Hang on just one moment. I'm going to grab a different calculator. We're actually just going to move that decimal place one more to the left. So that gives us, I guess I could have done that in my head, 5.0 times 10 to the negative fourth moles. Okay, so this is 10 to the negative third that we started with. We multiply it by 0.1, and that's going to move it one more place to the left of NaOH. Okay, good. So now what we need to know is that the unknown moles and the acid moles and the base moles are in a 1-to-1 ratio. So, since we have a 1-to-1 ratio, okay, so we have 1 to 1, the moles of our acid, HC2H3O2, are also going to be this value right here. Okay. The last step that we need to add in this, at the end, we need to find out the unknown molarity. So the unknown concentration molarity, which was our acid, okay, so HC2H3O2. And in order to do that, we're going to take the moles, 5.0 times 10 to the negative fourth moles of our acid, okay, and we're going to divide that by the liters of our acid. So we're going to take 0.0100 liters, and I calculated that one out already, and we get 0.050 molar of our acid, HC2H3O2.